All right, Math 1 honors people. Welcome to Unit 9. Still a geometry unit. We're going to talk about coordinate proof. Hopefully you have already done that discovery about the distance formula and the midpoint formula. Hopefully you didn't just look it up. You actually used your mind and used the visuals that were given there and derived the formula on your own. That's kind of the idea of that. I typically do that with my regular Math 1 classes as well as my honors classes. So I want to talk about coordinate proof in a minute here. You might be asking yourself, what did we miss in Unit 8? Because we skipped a unit because of this, less time to get through the year. You skipped a unit that discussed these types of four-sided shapes called quadrilaterals. And you might think you know about them. I would bet money most of you don't know about them because we don't teach much about them. You might have a middle school teacher who did a little bit with them, which is great. But generally speaking, they don't teach to the depth that we would have taught in an honors course. So quick little overview. If you want to jot these things down, it's helpful. If not, if you think you know them all, good. We're going to be applying some properties of quadrilaterals that you may have seen before. This first one you probably recognize is a parallelogram. And the definition of a parallelogram is two sets of parallel sides. Now, there are lots of other properties of parallelograms you might know about, but none of those define what a parallelogram is. The definition of a parallelogram is, and that's why the word parallels in here, is two pairs of parallel sides. So a four-sided shape with two sides of parallel sides. Now, there are other properties. You might also know that the opposite sides will be equal, so the left and right would be equal, and of course the top and the bottom would be equal. That's another property. You might also know the opposite angles would be equal. If this was 60 degrees, this one here would be 120 because you have parallel lines. If this was 120, that would also be 60. There's your 60s. If this was 60, that would be 120. So opposite angles are congruent. Those are some additional properties. There's probably many other properties about parallelograms that we would discover if we were doing Unit 8. This green one here, I'm sure you can identify as a rectangle. But if I was in class and I asked you to tell me the definition of a rectangle, at least half of you, even as honor students, would probably get this wrong, just because you haven't been taught the specific details of what a rectangle is, and you've been allowed to make false conclusions. Some people would say, oh, a rectangle is a shape where the opposite sides are congruent. That is a property of a rectangle. That is not the definition of a rectangle. That would not define this shape. That would define this shape. Specifically, a rectangle is a figure with four right angles or four congruent angles. So it's a quadrilateral. You'll see I abbreviated that here with four right angles. That is the definition of a rectangle. That is the only way to define a rectangle. And again, a rectangle has other properties. It has all the properties of a parallelogram because if these are all right angles, the top and the bottom will be parallel. The left and the right will be parallel and it'll have these same properties. So it's an example of a specific type of parallelogram. Third one on here, if I were in class, I'd say, what kind of shape is that? Lots of people would excitedly raise their hand and tell me that it's a diamond. Well, a diamond's not actually a shape. A diamond is something you spend a lot of money on when you buy someone a present. It is not a figure. It's not a shape. My third grader and my kindergartner are using the word diamond incorrectly because they're being taught that in schools. Unfortunately, it is not a geometric figure. The name for this shape is not diamond. The name for that shape is a rhombus. And some of you, I'm sure, know what a rhombus is. A rhombus is a figure with four sides where all of those sides are equal. There are things called kites that look like diamonds. If I asked people to define what a diamond was in class, I don't think people could do that. I don't think they'd actually know what a diamond is. Whereas a kite you can define, a rhombus you can define. So there's your definition for a rhombus, a quadrilateral with four equal sides. Very similar to a rectangle, only one word is different, angles versus sides. So they're almost the same exact thing on here. Four congruent angles, four congruent sides. Or four right angles and four congruent sides. Now, usually somebody in class goes, no, that's not right. You just gave me the definition of a square. No, this is not the definition of a square because this says nothing about the angles. You'll see these angles can be acute or obtuse, and it's still a rhombus. This often happens. You get a flat tire. You typically use a rhombus to fix that flat tire. You pull out a jack, and somebody turns a little wheel, and that wheel raises the car, and that little figure that's raising the car is a rhombus where all four sides are the same. It is usually not a square unless you crank that thing up really high off the ground. It's usually not a square, but it is a rhombus. Fourth figure on here you'll see is a combination of all of these figures. It's a type of parallelogram. It's a type of rhombus. It's going to have these qualities. It's going to have four congruent sides. And like the rectangle has four congruent angles, this right here is a rectangle. This is a rectangle. That's a rhombus. That's also a parallelogram. We call that a square. So a square, if you were to write the definition of a square, it would have both of these qualities: 4 right angles and 4 congruent sides. So something can be a rhombus but not be square. Something can be a rectangle but not be square. But if it's a square, it's all of these figures above. Now the last figure I have on the screen here, the 5th one on here, this blue thing down here at the bottom, is none of the above. These have nothing to do with this bottom one. You notice in all of these, you have 2 sets of parallel sides. This is the figure that has only 1 set of parallel sides. And there is a group of students who often mix the word up, rhombus and trapezoid, for some reason. I don't know why, but a trapezoid, maybe they were taught by some teacher somewhere, I don't know. A trapezoid is a figure with exactly 1 pair of parallel sides, and sort of by definition has 1 pair that are not parallel. So the left and the right in this case are not parallel. The bottom and the top you could show are parallel. One little caveat of that, it could be a type of trapezoid where 2 of the sides are equal. We call that an isosceles trapezoid. And somebody usually asks, could the top be congruent to these? It could be. There's no name for that, but you could have 3 congruent sides technically, but you definitely can't have 4 congruent sides, because then that would make it not a trapezoid but a rhombus. So this does not have the nice qualities that these have here. It's got 1 set of parallel sides. Certainly trapezoids come up a lot. In real life, they're used geometrically all over the place. If you look around the world, you'll see trapezoids. You'll see all these. These are the 5 big ones, I should say. So hopefully you've got that. And this is an introduction to what you missed. I'm spending 6 minutes talking about what you missed. Unit 9 is going to, have these shapes on graphs, essentially. Doing things with slope, doing things with the distance formula, doing things with midpoints. These are not 2-column proofs. I'm going to use the word proof, but the expectation is you're not doing a 2-column proof with statements and reasons on the other side. Generally speaking, and you could do them that way, but I'm not going to show them that way. Generally speaking, a coordinate proof is a combination of words, calculations, and often words explaining the calculations and the conclusions from the calculations, and possibly could be graphs. You might be making a sketch of a graph to support your calculation, your words. The graph doesn't have to be there, but it often is, because it's a coordinate. It's a coordinate proof. It's on a coordinate plane. So just to clarify that, that's an important detail to be aware of. I'm going to come back in the second part and actually get into example 1 here if you haven't done it yet.